All right, let's go ahead and code this up. I've included a vector real quick and create a quick little main. So let's go ahead and create a vector of something. We'll make a vector of integers because that's always the easiest. Let's see. What should we call it? We'll call it PQ because we are completely unoriginal. And ooh, actually, how do we initialize that? We can do it that way? That's awesome. All right, what elements do we want?
2, 7,
17, 38.
Oops.
That works too.
38.
Finally, somebody got the joke.
No, I was laughing at a 674.
Oh.
You should put 674 in there. I like that.
678. 482. 482.
12.
666.
All right, we're done. All right. So if we wanted to print, well, actually, let's see if that works because I probably need to put my STDs in front of it.
Oh, yes, you need to put your sample list in front of it.
Priority queue. Oh, it's wrong. PQ must be initialized by constructor, not by this. Oh, well, let's fix that. Dash STD equals, what was it, C plus 11? Yeah. There.
Also, this is just for the class in general. You can use C++, 11, and 14 for the projects.
Sure. No problem.
That helps a lot.
Okay. Probably should update that with my... Remind me afterwards to update to C++ 11 for the autograder. It's really easy. I just haven't done it.
I will.
Because it's real simple to do. I just haven't done it yet. All right, here we go.
Makes my life easier too.
So we have a vector, and then what was the next thing? We need to call a make heap. I wonder what we have to include for that. C++ make heap. Algorithm. Oh, we got. All right. Include algorithm. Wait, did I spell that right? I did. Good. So we can do make heap on pq.begin, pq.end. Let's see if that compiles. It did. Does it run without failing? It does. Okay. You know what? Let's go and make a quick little print thing to see if something's working. See if it's working. Sorry. PQ. Oh, that was weird. How do we do this? Does anyone remember? How do we print a vector?
Oh, a vector?
Yeah.
Iterator.
Right? Let's see if I typed that correctly. I did. While it dot. Nope, that's not it. For it does not equal it dot end. It plus plus.
Oh, yeah.
Yeah. See out. We'll go and put the, what was it? Star on the iterator. And we'll go and add a space. And then at the end, we'll put a backslash in. Let's go ahead and compile and run. Ooh, not quite. See out, because we didn't include IO stream. And it's not it.end, it's pq.end. Not declared in the scope. Wasn't?
That's PG.
Oh.
Yeah, you were the program.
Alright. So we'll print it here, and then we'll print it after the make heap and see if it did anything. Yeah, it looks like it did stuff. Oh, who's on top? The 6, 7, 8. So the highest. Huh? Who's on first?
It didn't work.
What do you mean it didn't work? In the C++ one, the highest is going to be. So is 6, 7, 8 the highest element? Because he's first, so he's the highest. So 6, 7, 8 bigger than 482 and 6, 7. Yeah, 6, 7. That's true. Is 6. All right. So then is 482 greater than 64 and 38? Yep. right into
God,
it
it's
stuff?
weird.
Yeah. Oh yeah, yeah, a little weird.
It's in like pairs.
Yeah. So it looks like it did it. That's nice. That's nice.
It's always nice.
So let's go. All right. You never told me to comment, guys.
Hey, come.
Comment.
Thanks.
Don't ever say I didn't do anything for you.
Hang on to us.
Yo,
You need cop.
make the heap using STL,
I mean, we can comment for you, but
and I'm just gonna print it out again. All right. So now, what do y'all want to do? Add to it, remove,
remove.
remove. All right. Remove. So see out. We'll just say, what was it? PQ.front is in the front of the queue, removing. And then we'll do, what was it? Pop heap. What was it? Is this PQ.begin and end again? Hopefully. Yeah.
Yes.
Good. In PQ.end in front of Q removing, and now we'll say is in the front of the queue. And then we'll print it off again just for funsies. Alright, we'll go and run that. So 678's in the front of the queue, makes sense. Now 674 is in the front of the queue, because that guy got shifted up, and then did some of the, yeah, all the other elements changed up. Great. Ooh. What happened there?
It just added it.
To the end. Oh wow. So you need to actually decrement. So yeah, another thing you actually need to do, and the instructions didn't say it, was pop back.
Why?
You need to do pq.pop back.
Why? Because you said so.
Well, notice that the 678's at the end, right?
Yeah.
So now if you pop the back, then it actually removes it from the queue.
Oh.
Because all that heap did was move it at the end, which is technically what it does. It swaps, you know, the front, the first element in the back, and then sifts down the front guy. So you need to go ahead and pop them back in order to actually remove it from the heap.
So when we move a specific element to a new spot, we then need to also remove it from its old spot too.
Right, and it's always, the heap's always going to put it at the end, or a pop heap is going to put it at the end, so go ahead and pop the back afterwards.
Okay.
Yep. Puts the first element in the back. Removes the back element. Alright, perfect. Now let's go ahead and do add an element to the priority queue. What do you want to add?
63.
Alright, hold on. It's in the front of the queue, and we're going to, let's add a big number. Add 9,000
And 1.
and 1. That's right, this is the 9001 class.
It's over.
It's over. Okay, so first we push it back. That adds to the vector, to the vector. And then we need to do, what was it, push heap, pq.begin, pq.end, and that'll sift up the last element. And then we'll now say whatever it is in the front of the queue. And we'll go ahead and print the queue afterwards. All right. Everyone good with me so far? Good.
Yes.
So, 6.7's in the front of queue, adding 9,001. 9,001's now in the front of the queue. 9,001 got shifted up there. 674 got pushed down. Looks like 482 got pushed down to here, which replaced, I think it, which it replaced? 38? Yeah, and the 38 got pushed to the back. Haha. Okay.
Okay.
All right. Any questions so far?
For a lab, are we making functions that do each of these?
Yes. got it.
Awesome.
I'll need to put up the autograder afterwards.
Yep.
All right. So that.
Can you do C++ 14 instead of 11?
Let's find out. Now. Okay, good. It still works. Now, before I continue, remember that G++, the version I'm using,
Is 98.
is no.
Oh, 3?
Hang on. 4.9.2. The latest is 6. Keep that in mind. Okay.
Okay.
The reason of the shift is because GCC 5 has been giving people some problems.
How so?
Just got compatibility issues. And that's why 4.9 has been used in Debian for so long. They're going to, Debian is just going to, it's actually going to jump from 4 to 6 in their next full release, but they're trying to work it out. 6 fixed a lot of issues. They're just ironing it out, right? So hopefully soon 6 will come out, and then this class will be version 6. But keep in mind that GCC version is only 4.9 for this class. I will enable C++ 14, but the reason I say you need to keep that in mind is GCC 4.9 does not implement all the features of C++ 14, nor does it implement every single last one of 11.
A good example, this is just more for the class, is when I set my code, the textbook was using null PTR, or null pointer.
Mhm.
So if this is equal to a null pointer, return whatever. You can't do that. You would have to use the actual NULL instead of null pointer, because on the autograder it goes, hey, I don't recognize this.
Right,
I've had
right.
that happen to me before.
I'll enable it, but keep in mind the GCC version is 4.9, okay? Just keep that, make sure it's supported. It supports all of 98, which is going to give you a lot. It supports most of 11, not all of it, but definitely most of it. Probably everything you're going to use from 11. And it only supports a handful of features from 14.
Are you going to move to 17 anytime soon?
17 anytime soon? Hopefully, yeah. Like I said, version 6 from GCC. I'm sorry. Debian's going to move to version 6. They said they're going to release it sometime this year. So, and when that happens, we will migrate to 6. Hopefully that'll happen before the next class in the fall. Thank you, in the fall. But just keep in mind for this class, 4.9. And this, you may think that's not cool or whatever, but keep in mind when you go into a real environment, they're going to have the same issue. There's only going to be certain versions of tools they allow. Yes?
But I would, let me play devil's advocate. I think you should also stay at C++ 98 as much as I don't want you to, because you would be working with legacy code. So if you understand legacy code to much of an extent, that can also help in the real world too.
Yes, that's true. You could go either way with it.
Yeah, I'm just saying.
It doesn't, but most of those features are really just helpful features more than anything.
Yeah.
All right. Anyways, a couple of other things. Helpful functions. I don't know why the slide came out that way. So the heap functions, the list of ones that you'll probably ever use is make heap, basically heapify vector, pushback will push heap, pushes, pop removes, front gets the top element. We just did those. You can call sort heap, which performs heap sort for you. Isn't that nice? However, keep in mind when you do that, the vector is no longer a heap afterwards.
What?
Sucks to suck.
So you're sorting it as a heap, but then it's not a heap.
Afterwards. All right, here, let me show you what's going on.
You deheapify it.
And what was it? Heap underscore sort underscore heap. Let's do heap sort. Sort underscore heap. We'll probably do pq.begin, pq.end, and then we'll go ahead and print it. So notice what happens at the very end. Let's see if I did that right. Whoops. Probably a miscompilation. Yeah.
Oh.
Right. Your vector has now been sorted. A sorted vector is not a heap, necessarily. Chances are it's not. Let's put it that way.
Most likely.
Most likely it is not. But now it's been sorted using heap sort. That's all.
Can you make it go back?
Sure. What would you do?
Delete it.
Or do you just do make heap again?
Yeah, let's go back. Make heap. Hey, look, we're back.
Okay.
Notice, oh, this is interesting. The heap, we had the heap, we sorted it,
Different.
and then we have a heap again. It's different, but it's still legit. Both of those representations are correct. There are multiple representations of a heap given a piece of data. So that was a great example. Thank you, Kate.
What I'm here.
All right. Is heap, quick test to see if you're still in a heap. And is heap until is a little confusing. Returns an iterator of what part of the vector is a heap. So if your heap, your vector, like some of it's already been removed, this will return which portion of your heap is still a heap and then ignore the rest. All right, comments. Let's see what the author of the slide says. Priority queue is a data structure that's designed to return elements in order of priority. Great. Efficiency is usually measured, blah, blah, blah. Simple implementation to co-op in, which are terrible. A heap implementation like slogin, which is far better. Thus, any sort of heavy-duty use, a heap implementation is better.
That's an opinion.
What?
It's an opinion. Heap sort is better.
I don't know, that's pretty objective. Simple implementations of n, heap is O of log of n.
Yeah.
And we've shown that log of n is superior, aka better. Please, Jonah, I would love to hear your disagreement.
No,
Go ahead.
I-
Voice it for everyone.
I am all for the heap implementation.
Yeah, it's a better implementation, but it's still our opinion. It is not a fact.
All right, well, I'll write this question on a final, and when you get it wrong, I'll deduct points. Does that
She'll
help?
leave like a paragraph on why it's an opinion.
I'll take off extra points because it's like,
Yeah.
stop being.
That reminds me, our linear algebra homework had an opinion as one of the true-false things. I was like, that's an opinion.
Oh, well, you know who else does that? Dr. Greaves, you know what he'll do? So sometimes you put a question on one of my, on the test saying, what's the best way to cook a chicken? And it was actually, what are the questions? And I guess it actually was worth points.
Good job. So the recommendation of this author, not necessarily mine, is if you need a priority queue, define it as an abstract data type, which is what we're going to do in the lab. Start with a simple implementation, keep the implementation hidden so you can change it later. Just use a heap. It's not that hard in STL. They actually made it pretty easy. Hopefully y'all can see that.
They did something right.
They did something right. All right. Any other questions before we talk about the lab?
No.
All right.